Alright, let's go ahead and look at number 4. It's a little bit different. Did you get all of the end of number 3? Make sure you got the, ooh, that's ugly. Vertical stretch by a factor of 1/2 and a rocks. So we had a shift and vertical, not stretch but shrink, wasn't it? Vertical shrink by a factor of 2, or a factor of 1/2, however you want to say it. And we had a rocks. Our end behavior as x goes to negative infinity, f of x is undefined. And as x goes to positive infinity, f of x goes to negative infinity. It's going downwards. You could start asking yourself, when will the first one be defined? We haven't had a reflection over the y-axis yet, but this would do it. The negative inside the radical. And in that case, then as x goes to negative infinity, y would go to positive infinity, or whatever other transformations you have. So, okay. If you need to pause, go ahead and pause. Let's look just briefly at the cube root. We'll see what we can get through. Alright, looking at number 4, let's first talk about what the parent function would look like. So using y equals the cube root of x as our parent function. When x is 0, y is 0. When x is 1, y is 1. But also when x is negative 1, y is negative 1. Our next cube root is 8. So if we put in 8 for x, we get out 2 for y. But since cube roots can handle negatives, we can put in negative 8 for x and get negative 2 for y. And our parent function curves a little bit there, and then the curve changes. So we have concave up on the left, and this is concave down on the right. Alright, so there's our parent function. Here we have, we've got a negative 3. And for x, maybe we should use a different color, sorry. So this is going to be a vertical stretch by a factor of 3. And it's also going to be a rocks. Alright, so this function here starts at 0, 0. But when I put 1 in for x, I get a positive from the cube root, but times negative 3 gets me down to negative 3 down here. My next perfect cube is 8, so I put 8 in for x. Here's my 8. And normally it would be 8, 2. The cube root of 8 is 2, but 2 times negative 3 is negative 6. So we get way down here in the corner. And you can see this side is going like this. Should be, if I could draw correctly. Try that again. And now what was kind of concave down is now the opposite, concave up. Let's look at the negative side. When x is negative 1, y should be negative 1, but negative 1 times negative 3 is positive 3. And when x is negative 8, we should get negative 2, but negative 2 times negative 3 times that vertical stretch, it's going to be positive 6, vertical stretch in the rocks. So we'll get something like this. Okay. And it continues down. Alright, I'm not going to do the table on these. I can do them later if you need, but let's see if we can get through a few graphs. And let me give you a couple hints, and maybe we can get through this lesson. Okay. Domain is negative infinity to positive infinity. Range is negative infinity to positive infinity. Transformations, we already said that. We have a rhox and a vertical stretch by a factor of 3. In behavior, as x gets negative, y actually gets positive because of the rhox. So y goes to positive infinity. As x goes to positive infinity, y goes to negative infinity. Okay, if you need to pause and get that written down. I know I'm going a little fast, sorry. Zoom out for you. Okay, moving on. Alright, number 5. We got a doozy here. So we look at our HK. Remember that H is the opposite of what it shows, and K shows what it does. So although it says plus 3, it's supposed to be x minus H, so H needs to be negative 3, and K is negative 2. This is not called a vertex, but it would be a point of inflection. So negative 3, negative 2 is down here. And this is kind of our starting point for our graph. The A value, we have a vertical stretch of 2. So our parent function starts at 0, 0, and when x is 1, the cube root of 1 is 1. When x is 8, the cube root of 8 is 2. So it looks something like that. Ooh, I totally missed that. Try again. When x is negative 1, y is negative 1, the cube root of negative 1 is negative 1. When x is negative 8, the cube root of negative 8 is negative 2. So this is just our parent function. This is the function y equals cube root of x, and I'm plugging in values for x. Those values I'm plugging in are, well, values are 1, 8, negative 1, negative 8, and 0. So let's look at the function we're asked to graph. So we've got our left shift and downshift taken care of. Normally we would go over 1, and the cube root of 1 is 1, but it's going to be 2 times. So it's going to be over 1, but it's going to be up 2. So when x is negative 2, y is actually 0. You can plug that in and check. Normally we would go 8 from the point of inflection. So 1, 2, 3, 4, 5, 6, 7, 8. That's not right. 1, 2, 3, 4, 5, 6, 7, 8. Here's the 8. Normally we'd go 8, 2, but we're stretching by a factor of 2, so we're going to go 8, 4. And it looks like it's on the yellow line, but it's not really. So when x is 5, y should be 2. You can check that out. Can't go any further, but we can go backwards. So normally from the point of inflection you would go negative 1 down 1, but it's stretched by a factor of 2. So we're going to go left 1, down 1 from our point of inflection. We normally go 8 from there. So negative 8 from our point of inflection should be down 2, but stretched by 2 it's down 4. So we should have these points negative 4 on our graph, and negative 11, negative 6. Connect that out. So yeah, not very pretty, but I think at least the points are accurate. Alright, so our domain is negative infinity to positive infinity. X can be any value. Excuse me. Our range negative infinity to positive infinity. Transformations were left, left 3 down 2. So shift is the word I'm trying to write there. Shift left 3 down 2, and then vertical stretch by a factor of it was 2, wasn't it? Yeah, by a factor of 2. As x goes to negative infinity, that's the point. Let me zoom out. As x goes to negative infinity, that's this point over here. Y is going to negative infinity. And zoom out again. As x is going to positive infinity, that's going to be this point over here. Oops, sorry. This point over here, so y is getting bigger and bigger. Y is going to positive infinity. Let me hold off on this one and show you real quick. If you want to check your graphs, you can look at Desmos. So if you haven't downloaded Desmos, I would do that now. I think I'd rather just start with a new. So I'm going to hit my 3 dots and go to New Graph. Doesn't really matter. I guess we'll do this one. Sorry, I thought this was ready. Let's close these out. XX. And in here, I'm going to add an expression. And let's do square root of x. So y equals square root x. And there it is. Say we wanted to put a transformation on that. So just move your cursor. Let's call it negative 0.5. And we can do x minus 2. And outside we can put plus 3. And there's kind of our graph. So you could check points there if you wanted to. So whatever points that you thought were right, it'll give you a little bit of idea. It doesn't give you exactly, so you kind of use your best judgment. Okay? So putting these equations in Desmos can give you a good idea of where you're at. To do a cube root, you're going to have to use a fractional exponent. Can we do it? I think so. Got about a minute. So y equals x to the, and I'm going to delete that 2 and put in 1 divided by 3. And looky there. Isn't that lovely? There's your parent function. Okay, the home button will center it for you. If you press that little home in the upper left, you get my equation back. And you can put in your transformations. You might want to put in parentheses in there. So x, should we do minus 2? I'm going to close that parentheses. And now you see it shifted right to. Put something on the end. Let's put minus 1. And there's that. You want to stretch it, put a 3 out front. Woo! Hit our home button. Clear these things off. So I'll give you an idea of what's going on. So the points are hard to tell. It doesn't pick up the points quite as nicely as